So the distributive property is arguably the most important property we'll talk about, just because it shows up so much in the middle of solving problems that you want to be able to recognize it and go, hey, that's the distributive property. Let's use that here. It'll make things a lot faster and easier for you. So what is it? Well, the distributive property is used when multiplying a number and a sum or difference expression. So that might look something like this. We'll call A our number, and then B plus C, well, that's a sum expression. So we're multiplying A times B plus C. Again, it can be used to multiply a difference expression, and difference just means subtraction. And what we're going to do here is we're going to distribute, or we're going to multiply all the terms on the inside of the parentheses by the term on the outside. So oftentimes you'll see people draw these lines from that outside term going into the sum expression. So that's what we'll do here. So we'll do A times B, which is just going to be, we can express it like this, AB, plus A times C, times AC, or plus AC, I should say. Same thing down here, and it's no different even though there's a minus sign. So we'll do A times B, which is going to be AB, and then minus A times C. You'll also see it sometimes, really not ever, not at all, but the distributive property works the other way around, or if we use the commutative property, right, the ordering of our two terms, if we change the order, the distributive property will work the same way. So what I mean by that is if I put B plus C first and then times A, we can just distribute going to the left, and it works the same exact way. So we will get B times A plus C times A. And then if we did it with a difference expression, so B minus C times A, well, that's going to equal B times A minus C times A. Again, you really will never see it expressed this way, and if you do, just rewrite it so that it looks like one of these two over here. Let's walk through a couple of examples using the distributive property and only using numbers for now. So when I have the number on the outside, right, I distribute it to the terms on the inside of the parentheses, or I multiply the outside number to the numbers on the inside of the parentheses. So I'll have 9 times 1 plus 9 times 2. 9 times 1 is 9. 9 times 2 is 18. 9 plus 18 is 27. All right, same thing here on the bottom. So we'll distribute the 10 to the negative 9, and then the 10 to the 10. 10 times negative 9 plus 10 times 10. 10 times negative 9 is negative 90, and then 10 times 10 is 100. Negative 90 plus 100 is going to give us a positive 10. All right, over here we're going to distribute the negative 3 into both terms of the parentheses. So negative 3 times 5 plus negative 3 times 10. Negative 3 times 5 is negative 15. And then negative 3 times 10 is negative 30. So I can just go ahead and write minus 30, because adding a negative is the same thing as subtracting a positive. So negative 15 minus 30, I lost $15, then I lost $30 more. It's going to be negative 45. And then down here, we'll distribute the negative 7 into both of those terms. So negative 7 times negative 2 is going to be 14. And then negative 7 times negative 4. Whenever you have a negative sign to the left of the number, it's attached to it. So that's why I'm just writing negative 7 times negative 4. That's going to be 28. And I just add these two terms together, and I will get, what is that, 42? Yeah, 42. I want to do one quick example with a bunch of terms on the inside of the parentheses just to show that the distributive property works the same way as if there were just two. So let's do it the order of operations way first. So we'll take care of what's inside the parentheses first. So 5 times 4 plus 3 minus 2 minus 1. If we do inside the parentheses first, or do what's inside the parentheses first, I should say, 4 plus 3 is 7, minus 2 is 5, and then minus 1 is 4. So I'll have 5 times 4, which is going to give me 20. So knowing order of operations, we can use that here, and we know that our answer should be 20 once we do it the distributive property way. So using the distributive property, again, 5 times 4 plus 3 minus 2 minus 1. I'm going to distribute the 5 to every single term here, all 4 of them. So I'll have 5 times 4 plus 5 times 3 plus 5 times negative 2 plus 5 times negative 1. 5 times 4 is 20. 5 times 3 is 15. 5 times negative 2 is negative 10. And then 5 times negative 1 is negative 5. So we'll do 20 plus 5, or 20 plus 15, I should say. That's 35 minus 10 minus 5. 35 minus 10 is 25 minus 5, and that's going to give us 20. It's more likely, however, that you're going to be using the distributive property when you come across variable expressions, like the ones I got here. So let's look at this yellow one, 5 times x plus 3. So we do the same thing. I'm going to distribute the 5 into the terms on the inside of the parentheses. I'll have 5 times x plus 5 times 3. 5 times x is just 5x. 5 times 3 is 15. So we'll have 5x plus 15. All right, we'll go down here. 7 times 3k plus 11. So again, we won't always use x as a variable, but the rules work the same. So we'll do 7 times 3k plus 7 times 11. 7 times 3 is 21, and we just leave the k hanging out there. Plus 7 times 11 is 77. So there we go, 21k plus 77. 2 times x minus 9. Again, just distribute the 2 in. 2 times x is 2x. And then 2 times negative 9 is negative 18. So I'm just going to stick a minus 18 there. All right, over here we have our the single term to the right of the expression. So I like to move it over to the left. And most people do that anyway, so you should too. So we'll just write this a bit differently first. So negative 8 times negative 2x plus 9. And then we'll distribute the negative 8 in. So negative 8 times negative 2 is going to be positive 16. And then we have that x, so we'll bring that down as well. And then negative 8 times positive 9 is going to be negative 72. So I'll just write a minus 72 there. All right, a few more examples. 1/2 times negative 10y minus 30. Again, just distribute the 1/2. And multiplying something by 1/2 is like dividing it into 2. So, or cutting it in half. So what's half of negative 10? Well, it's going to be negative 5y. Negative 5y. 1/2 times negative 30 is going to be negative 15. So we get negative 5y minus 15. You can also multiply variable terms or distribute variable terms into terms inside the parentheses. So here, down here we have x times x plus 7. So no different. I distribute my x in. I'll have x times x plus x times 7. X times x is x squared, not 2x, but x squared. And then 7 times x, or x times 7, is just going to be 7x. So we get x squared plus 7x. Similarly over here, 4x times 2x. I'm going to distribute the entire term there, not just the x and not just the 4, all of it. So 4x times 2x, and then 4x times minus 3. I'm just attaching that negative to the 3 there. 4x times 2x is going to be 8, and then we have the x times the x is x squared, so 8x squared. And then 4x times negative 3 is going to be negative 12x, so I can just put a minus 12. Last one down here, negative 11x times negative 9x minus 1. Distribute the entire term, the entire negative 11x, into the terms inside the parentheses. So we'll have negative 11x times negative 9x, so that's going to be a positive 99x squared, because I have the x times x. And then negative 11x times negative 1 is going to be positive 11x. And there you go.